Good evening. So we reached the final session. I'm Dr. Mohan. I'm a neurologist and co-founder of a startup, MCare Apps. We make mobile apps for care providers in medical emergencies like stroke. And let's start the session with Mr. Karthik Nandula, our first speaker. He'll be speaking on IoT-based automation systems for healthcare. He is from a company called Smarter Spider. It's the general manager of technology. And he's a electronics and communication engineer with an MBA in finance and marketing. So the company is into building automation and building smart by automating the fire and the water HVAC systems. And let's hear from him because, of course, healthcare systems also buildings and all of this will be relevant for hospitals also. So let's hear from Mr. Karthik Nandula.
Thank you, Dr. Mohan, for introduction. Good evening, everyone. This is Karthik here, and I'm here to explain you about our intelligent building automation system for healthcare. So through our system, we not only help our clients in monitoring and controlling all the utilities, but also help them in energy savings. Now, when it comes to a traditional hospital building, we have multiple utilities such as HVAC and chiller management, lighting, fire pump monitoring, oxygen or nitrogen pressure monitoring, energy mapping, water tank levels and pump on-off control, DG monitoring, elevator escalator on-off control, then OT monitoring, restroom monitoring, oxygenator consumption monitoring, and then outdoor signage and lighting control. Now, monitoring and controlling all these utilities is a tedious task for the engineering department or the facility management, as they are dependent on manpower for either monitoring of these utilities or on-off of these utilities. In this due process, a lot of energy gets wasted. For example, let's say a clogging of the filters is one of the challenges in some of the hospitals where we have done automation, which we found, and then more runtime, like instead of running between the fixed duration, it is running before and beyond the particular time and all. So considering all these challenges, we have a solution where all controls and monitoring is on a single platform. We have designed the system in such a way that it's affordable. When I talk about affordability, it can be deployed either in a small room, like for example, your temperature monitoring or your cold room monitoring and all, to even a multi-story building, to even a spread out campus. Then all our modules, the design has been done as smart and wireless. So it's so each and every utility has its own wireless module. It's a plug-and-play system, and because it's a plug-and-play system, it's easy to install. Typically, let's say a 6-floor building or a 7-floor building, which is already having around 20 AHUs or 20 to 30 AHUs, some 40 energy meters, your from 6 to 7 water tanks and all. So all it takes to complete around 6 to 8 weeks. Typically, ideal condition, 6 to 8 weeks is the time where I can automate all these utilities. And then wherever we have done our installation, the average energy saving is around 20%. And then last but not the least, it's a cloud-based solution. So need not to deploy expensive licenses or purchasing a server to maintain your entire utility system. As long as you have an active internet connection, the facility manager or the engineering head can monitor and control all the utilities from anywhere in the world at any given point of time. Now, coming to the solutions, so the list of utilities where we can monitor and control, it's a limited list, but it can be more. So HVAC temperature and timing control, lighting control, signage control, AHU filter monitoring, energy management, your restroom monitoring system, water tank level and control, DG monitoring, especially the fuel consumption, the chiller monitoring, elevator on-off control, air compressor monitoring, cooling tower monitoring, fire pump monitoring, UPS monitoring, and many more. So how we are doing is that we do a site survey of the complete building to determine what are the list of utilities that are required to be monitored and controlled. For example, let's say AHUs are there, your split or cassette ACs are there, then your room temperatures or temperature humidity or the room temperature humidity pressure exiting. So we monitor all these, we do a survey of the entire building, and then once we have a list of utilities that are required to be monitored and controlled, we divide the entire building into multiple segments, and each and every segment will have so each utility have its own wireless module. So they are mapped to a gateway. So this gateway is nothing but a communication bridge between the wireless modules and the cloud. So this gateway, so the internal communication between the module to the gateway is through a LoRa communication, which is called long range wireless technology. So its range is around from 300-400 meters in a closed environment, whereas it can go as far as 1 to 2 kilometers in an open area. And from the gateway, the communication between the gateway to the cloud is through a GSM communication. So we take care of the entire communication network and all we require is a 230-volt UPS power supply. And please note, sir, we manufacture all our hardware as well as sensors required for monitoring and controlling the system. So why smarter spider? So first of all, our system is truly modular, which means the decision can be taken as per the requirement and budget and can be expanded as per the requirements. So we have standard modules for each utility with facility for add-on sensors or modules as per the requirement, which I explain as I proceed further in the presentation. It's a wireless system and ease of deployment across the building. Takes days or weeks to complete the project. It's a simple and easy installation based on latest IoT technology, and then we have a robust and inexpensive online software and cloud charges. Currently, we are doing data logging every 10 minutes, and we can even provide faster data logging as per the requirement. And then we have complete data analytics with hour to hour, day quarter to day quarter, day to day comparison, week to week comparison, month on month comparison. And then in the due course, we provide an average savings of about 20%, sir. In a nutshell, we listen to you and we provide solutions as per your requirement. So why it's important? First of all, in today's scenario, you have to reduce the cost. It's very important. It has to be economical as the energy costs are rising. And then you have to reduce the risk of increasing energy demand. You have to control the energy demand for predictability. And then you have to reduce carbon emissions for promoting a green and sustainable image. So we have a saying, if you cannot measure and analyze it, you cannot control it. So our system is based on web-based wireless sensors and control, can measure the utilities wirelessly, has a low cost of installation, and then expanded as per the building requirements. So the system in a nutshell collects data and sends to the web server. It receives instructions from web control. User can analyze data and give commands to control. So applications for hospitals and healthcare. So we have HVAC monitoring and control, automated indoor and outdoor lighting control, diesel generator monitoring, water tank level and flow monitor, pumps on off control, air compressor monitoring, equipment on off control, fire pump monitoring, status monitoring, cold room monitoring, automated fresh or mixed damper control, then your chiller plant manager, cooling tower monitoring and control, restroom monitoring. In OT monitoring, we have room temperature, RH and pressure monitoring, energy mapping, oxygen or nitrogen gas pressure monitoring, then your consumption, indoor air quality index like CO2, PM, VOC levels, etc., freezer or chiller monitoring. Now, key features being remote controlling and monitoring of the entire facility. You can automatically take control of various operations. You can manage all the system, coordinate with various systems. You can provide a comfortable working environment in an efficient way. You can control, monitor, optimize the building service. It's a reliable and cost-effective recording of the utility consumption, reporting and analysis, and alarms for crossing preset limit. A partial list of customers which we have deployed like Apollo Hospitals, Hyderabad, MGM Hospitals, Chennai, Orthomon Hospitals, Coimbatore, Kaveri Hospital, Trichy, Nanjappa Hospital, Shimoga, St. John's Hospital, Bangalore, PRK Hospitals, Hyderabad. In pharma, we have Glenmark, Milax, Parmul Biosciences, Sun Pharma, and many more. So now when it comes to an HVAC, so the primary thing is we can, with our chill water based AHU module, so we can give an on-off command, know the on-off status, we can set the temperature, measure the return air temperature, measure the supply air, measure the delta T of it, then measure the chill water supply, measure chill water return, and then measure the filter pressure. That why we are measuring these filter pressures because of the clogging. We have seen cases in one of the hospitals where because of non-timely cleaning or non-proper maintenance due to clogging, there was an issue of infection. So once we have deployed our system now, because of we have an alert system where it will regularly alert the maintenance team regarding if it's crossing the set point, so they take care of the filter cleaning. So you have a clean flow air passing through the duct. Then we have 0 to 10 volt actuator control and feedback, and then we have a 0 to 10 volt VFD control. We have a fire input status and trip status. Now to this we have a facility to add on sensors, like for example, let's say you want to monitor the humidity levels inside the room, or you want to monitor the CO2 levels inside the particular area through the return air and all. We can add further more modules to it, like damper controls and all. Now this is for a chill water based AHU. If it's a ductable type AHU, then we have an on-off command, know the on-off status, set the temperature, measure the return air, measure the supply delta T of it, then unit on-off control as well as the compressor on-off control along with the filter pressure. Now, there are some hospitals where you may say, okay, we already have an existing BMS system, but that is restricted to only on-off, and you don't have a capacity to control the chill water. So we have a another module called where, with the help of the status on-off status of the HU, we can set the temperature that is required to be maintained inside the room, then measure the return air, supply air, measure the chill water supply, chill water return, and based on these 4 parameters, we can we control the actuator. Now, coming to the savings part, so what we are doing is we provide an average savings up to 20% through our delta T manager. So what we are trying to do here is, we're trying to increase the chill water return temperature, which results in an increase in the evaporator pressure, and which in turn results to the less work done by the compressor. And this is where we tend to save the energy. Now coming to the simulation, so this is a typical chill water type AHU where we have a sensor at the supply air, measure the TF from our duct pressure, then we have a temperature sensor for chill water supply, chill water return, what is called temperature sensor for returner, as well as fresh air and mixed air. And this is a type of for AHU for applications where you want to maintain humidity levels inside the room. So we have a heater control facility also. So this is the simulation is for an electronic heater, whereas if you have a hot water system running through the AHU, so we can modulate the hot water actuator also. So coming to other applications which we have is the OT monitoring system. So where it monitors the temperature, relative humidity, and pressure of your operation data. Control your OT, AHU, or CSU with respect to these parameters. And we can even provide optional parameters such as your VOC, P1, CO2, other parameters as per the requirement, and we have alerts for crossing the preset limit. Then you have an oxygen bank monitoring system where we can monitor the oxygen pressure. We can also monitor the oxygen consumption, and then if we have the parameters are alerts for crossing the preset limit. Now, the second point which I want to highlight is the fire pump monitoring module. The requirement for this module came from, like, during our surveys and installations, we found that the fire pump system in the hospitals, in most of the cases, they are either kept in manual mode or in off mode. In some cases, they are kept in auto. So, and also we found in one case that there was a pilferage of diesel from the diesel pump. And when you're doing a regular fire drill, instead of, like, as per the norm, depending on the type of how large the facility is, it depends on, sometimes they are required to do 30 minutes or some 1 hour. So we have seen cases where the supervisor runs the system for only for 5 minutes, but in the report they come as they write it as drill done as per norms, that is as per the required time. And in the due course, we have seen that diesel, he or she knows how much amount of diesel gets consumed using the drill. So he removes that diesel and sells it for personal to the trucks or autos which come for delivery. He sells it to it. So it's a very critical aspect which we found. Then second thing is we found that the water in the fire water tank is used for other purposes such as your gardening, cleaning, and other areas apart from your the fire purposes. So for that, what we have done is we have a system where we can check the status of the hydrant pump, sprinkler pump, jockey pump, or booster pump, whichever pump is there inside the building. Then we monitor each pump runtime to determine, like, let's say, for example, there is no jockey pump is running continuously. So how long it is running, nobody has an answer to that. So our system, you can determine how much time the jockey pump is running and when and how long the pump is running, and then monitor your diesel pump. So in the monitoring of the diesel pump, you can monitor your fuel level. That is the current fuel level, how much of the fuel that is poured, how much of the fuel that is consumed during the runtime, the battery voltage, and on the status. Then monitor your line pressure. So that can be done either at the pump room. Basically, we provide at the pump room, but if the client requires at different locations also, that we can provide. And then monitor the fire water tank levels. Currently, the data is updated every 10 minutes, and we have smart data analytics to understand how the pump is running. And coming to the next thing is a DG monitoring system where we monitor the fuel level in liters, fuel filled in liters, fuel consumed in liters, on-off status and runtime. And if it has an RS485 communication port, we integrate with that through Modbus. Coming to the system components which we have. So this is the gateway. So this acts as a communication bridge between the different wireless modules on the cloud. Then we can integrate with energy meters. This is the fuel sensor module, temperature, humidity, pressure module. And this is the module for your chill water AHU. So we provide all the required sensors. So it's a plug and play system, and typically a AHU gets automated within 1 to 2 hours ideal time, and we can control it. This is switch control module for monitoring or controlling any of the utility. Then the oxygen consumption monitoring module. So this is a screenshot of some of the dashboards which we have. This is for energy meter monitoring, complete energy mapping of the facility. Then your AHU data, so we can get what is the set temperature, return air, supply air, the delta T, chill water supply, return, actuator level, filter pressure, feedback, etc. Then simulation of the AHU, control settings for the AHUs, then the electrical consumption, so hourly consumption data, day-to-day consumption data, day-quarter consumption data, day-to-day comparison data, and week-to-week comparison and all, month-on-month. But this is for readings, temperature readings, kilowatt readings, power factor readings, pressure readings and all. We can have the data. So this is when you do a complete energy meter mapping, you get to understand where your energy consumption is happening at multiple areas. This is all about our system, sir.